So, good morning, students. We'll deal with multiple alleles today. Yesterday, I have explained you the difference between gene and allele. The difference between gene and allele. When I was dealing with terminology, I told you that all alleles are genes, but not all genes are alleles. This can be shown in the way that when we take one pair of homologous chromosomes, there are different loci, each locus occupying one gene for a character or trait. Thus, there are several loci. This is the first locus of first chromosome and the first locus of its counterpart. This is paternal, this is maternal. This is second, this is second. Third locus, fourth locus, fifth locus. So when I say corresponding loci, the first loci of these two chromosomes are called as corresponding loci. Likewise, the second are corresponding, third are corresponding. Here, both the corresponding loci of the first locus, here, the first locus, both the loci are responsible for only one character. Likewise, the second locus is also responsible for another character, but not the same character according to Mendel. That means as many loci are there, as many characters they code for. But we know that Pisum sativum is a diploid individual. It has two alternate forms. The character has two alternate forms which we call them as traits. One of which is dominant, the other is recessive. Thus here, the genes which code for one character are also again of two forms. So one character is coded by one gene. Because the character is having two traits, the genes are also two in number. And these two genes are called as alleles. One gene is said to be dominant, the other is said to be recessive. These are alternate forms of a gene present on the corresponding loci of a pair of homologous chromosomes in diploid individuals. Then only we call them as alleles. Thus, these two are alleles, these two are alleles, these two are alleles. But all these are genes. That is the basic difference between the gene and an allele. And according to scientists, till the discovery of after the discovery of Mendel's laws, everyone knows that there is one character determined by one pair of genes which are called as alleles. Okay? If it is a haploid individual, what happens? There will be only one chromosome, there will be only one character, one gene or allele. We cannot use the term allele because there is no alternate form for it. Haploid individuals have only one chromosome, one locus. There will be one gene. In diploid individuals, there are one pair of chromosomes. There are one pair of genes. We call them as alleles. If it is a polyploid individual, that means in haploid there is only one chromosome, diploid two chromosomes, and haploid the same first chromosome is represented 3 times. So that how many loci will be there? 3 loci will be there. So 3 chromosomes, if it is a triploid, for each chromosome is represented by 3 chromosomes. That means there will be 3 genes. If it is a tetraploid, there will be 4 chromosomes and there will be 4 genes. But we are speaking about none of the haploids, none of the polyploids. We are speaking about only the diploid individuals. Thus we have one pair of genes for the one pair of traits of a single character, which are called as alleles. Okay. After that, after Mendel, so many experiments were conducted in so many individuals, and in 1900, Mr. Karl Landsteiner, he discovered what we call it as the ABO blood group system. With the discovery of ABO blood group system, there come into the light a concept called as multiple alleles. Okay? When you say allele, it must be present on the same locus or corresponding locus of a pair of homologous chromosomes. Okay? Corresponding or same locus. According to Mendel, alleles are only one pair. But here it says multiple. Multiple means not just two. They are more than two. So, multiple alleles can be defined as more than two genes present on the corresponding loci of a pair of homologous chromosomes. But human beings being diploid, we have 46 chromosomes, and the genes for ABO blood groups are present on 9th chromosome. So let us say it is 9th chromosome, and the 9th chromosome contains only 2 loci for any character. So if it is a blood group character, it should contain how many? Only 2 genes. Let us say there is a gene for A antigen, gene for B antigen. Okay? So it codes for AB blood group. If there are 2 genes AA, it codes for A blood group. If it is for B group, it codes for, if it has 2 genes, it codes for B group. Then what about the O group? There is no representation here because we have represented only 2 genes, A and B. That means because there are two loci, only 2 genes can be present. Then what about the gene for O group? It has no locus here because we are having pair of chromosomes. Each individual is having one pair, only 2 loci, and only 2 genes it can accommodate. But multiple alleles are more than 2. Here for the blood groups, there are 3 genes. Here for the blood groups, there are 3 genes. But we can accommodate only 2. What about the other one? So what the scientists say is, multiple alleles cannot be seen in the same individual. They can never be seen in the same individual. Rather, they are seen in the population. So, I may contain A and B. I cannot contain gene for O because I have only 2 loci. Then what happens? There is another person with O group, and that one person contains the gene for O. Thus, when we speak about multiple alleles, we are calling them as alleles. That means they must be present on the same locus on a pair of homologous chromosomes. But as the same locus is said to be only 2 loci, we cannot accommodate all the multiple alleles. Thus, whenever we want to see multiple alleles, you cannot see in a single individual, rather you can see in a population of individuals. Then let's see how the multiple alleles originate. Let's see how the multiple alleles originate. Scientists say that multiple alleles originate by means of mutation. Multiple alleles originate by means of mutation. So let's say there is gene A for A blood group. So this person with A blood group on his ninth chromosome has two loci with two genes for A antigen, A and A. We can call them as simply. We will discuss about the inheritance later. Now what happened in the same person during the formation of gametes in the testis? Now what happened? On the ninth chromosome, there a mutation occurred. And let's say A gave rise to A dash. A gave rise to A dash. So I have told you before that there are two genes. One is called as wild type gene, the other is called as, can anybody say? The other is called as mutant gene. So here, out of these two, capital A is the wild type gene, A prime or A dash we can call it. This is called as the mutant gene. So which one of these two is dominant? Wild type or mutant?
Wild type.
So wild type is said to be dominant and mutant is said to be recessive. So here A is dominant over A dash. Now what happened? So I gave birth to my son, and my son, after getting marriageable age, he got again what we call it as ninth chromosome. During the formation of gametes, let us say what happened in that individual, this A dash gene got mutated. Gene got mutated. So he will be having A double dash. So thus we have three genes now. One is A present in one individual, from which A dash originated due to mutation, and this person can have both capital A or A capital A dash, or A dash and A dash. That means only two genes. And in another case, in another individual or in a group of individuals, the second gene got mutated and it gave rise to A dash. Okay, so this A dash is originated from a single dash. A double dash is originated from a single dash. So here A single dash will be wild type gene for A double dash, and A double dash will be the mutant gene. Thus now we see that A dash is dominant and A double dash is said to be recessive. Thus in multiple allelic series, a series of genes we can see in the population on the same locus on the same pair of homologous chromosomes. So ninth chromosome of me having only capital A genes. Ninth chromosome of another individual is having A dash genes. Ninth chromosome of another individual is having A double dash genes. Ninth chromosome of another individual may be having A single dash. Another individual A single dash, A double dash. In all these combinations, what we see is A is said to be the first gene that is formed in this multiple allelic series. What is this series? A dash and A double dash. So because A gave rise to A dash gave rise to A double dash, what happens? A is dominant over A single dash and this one is dominant over the double dash. Thus here A becomes the dominant over all the others multiple allelic series and this becomes recessive. And this will be the dominant gene for this recessive gene. And if in due course of time, let us say another gene is evolved and capital A is dominant over all these three. A single dash will be dominant over these two. A double dash is dominant over this one. So such a type of dominance recessive relationship is called as gradation of dominant recessive relationship, which is characteristic feature of only multiple alleles, not seen anywhere. Gradation of dominant recessive relationship. What is gradation of dominant recessive relationship? Here one gene which is said to be wild type is dominant over all the other alleles which originated from this in due course of evolution due to mutation. Thus A will be dominant over all the others. And the second gene, which in this multiple allele series of 4 genes, the second one which got originated from the first one is recessive to the first one, but it is dominant to the other one. That means the same gene can act as dominant to its wild type. So the same gene can act as, here a single dash, can act as recessive to its wild type, that is capital A, and it can act as dominant to its A double dash gene, and such a relationship is called as gradation of dominant recessive relationship. Now let us define multiple alleles with this introduction. So what are please.
Then it means ఒక టూ క్రోమోజోమ్ కి డామినెన్స్ అనేది ఎక్కువ ఉంటేనే కష్టం అర్థం.
డామినెన్స్ ఎప్పుడు ఎక్కువ ఉండవు. ఇప్పుడు
As mentioned, A is dominant to A dash and A dash is dominant to A double dash. ఆ రెండు ఒకే క్రోమోజోమ్ అదే ఒక క్రోమోజోమ్ లో రెండు లోకస్లు మీదనే ఉన్నాయి కదా సార్.
రెండు లోకస్ మీద ఉంటాయి. ఓకేనా? ఫస్ట్, సో దిస్ ఇస్ 9th chromosome of mine. I have A and A single dash. So which one is dominant now here?
A, sir.
So A is. So I will have A blood group because it is recessive. Now I am taking your genes, your chromosomes, 9th chromosome, on the same first locus. You have this combination, A single dash, single dash. What will be your genotype? A single dash, single dash. And what will be your blood group? A single dash only, your blood group. But another individual we are taking A single dash, A double dash. Now what will be the blood group here? A single dash only. Why? Because here A1, A single dash is dominant to A double dash, but the same here is recessive. So the same gene can dominate, can act as recessive to its wild type, can act as dominant to its mutant gene. So here we cannot call all these as dominant genes. Sometimes it acts as dominant and the other times it acts as recessive. Okay? Clear?
Yes, sir. Yes.
Okay, let us define multiple alleles. Multiple alleles are two or more genes, as I have said before. Multiple means they must not be two. Mendel said there are only two genes for a character called as a pair of alleles. That is principle of unit factors. And here we are saying that it is multiple means they are more than two. So multiple alleles are more than two genes, two or more genes which occupy the same locus. They occupy the same locus in a pair of homologous chromosomes which determine the same character. But we can see all of them not in a single individual but in a population of individuals. So thus you have to remember these points. First point is these are more than two in number. Second point is these are present on the same locus of a pair of homologous chromosomes. Okay? The next one is they determine the same character. They determine the same character. And fourth one, they are seen in a population of individuals, but not in a single individual, because single individual has only two loci, and these genes are more than two in number, and at any given time one individual can accommodate only two genes, and thus when we want to see the third gene, you have to go for the population. In the population on the same chromosome, on the same locus, the third gene will be present, but not in the same individual. And all these arise only by mutation. This is the fifth point. Is it clear, the definition?
Yes, sir.
Oh, can anybody tell me the definition now without seeing? What are multiple alleles?
Presence of genes more
Presence
than
of
two
genes
or
more than
more.
two or more.
Very good. They are more than two in number.
It present
It
number of
present
genes
number
present on
of
same
genes
loci
present on same loci
in
They
a
are present on the
population.
in a
same
population.
this. They
Loci
are
of
present on the
Loci of
homologous chromosomes.
homologous chromosomes.
very good. A pair of homologous chromosomes. Good.
They
They
possess
possess
same
same
character.
character.
They determine the same character. Okay. They determine the same character.
It
It
is
is
present
present
in
in
population.
population.
They can never be present in the same individual. All the multiple allele series, genes of multiple allele series can never be seen in the individual. They can be seen only in the population. Then how they originate?
Due
Due
to
to
mutation.
mutation.
Very good, excellent. They originate always by a mutation. So this is what the definition of multiple alleles. So the same, let us see in the form of characteristics. The first one is they are more than a pair of genes. That means they are more than two in number. They occupy the same locus of a pair of homologous chromosomes. They can be studied only in a population of individuals. Okay, that means only two alleles of the multiple allelic series, we call it as a series, shall be found in a diploid individual. So we are referring to only diploid individuals, don't forget that. All the genes of the multiple allelic series determine the same character. Okay, because they are present on the same chromosome, A and A dash here, and A dash A double dash here. This is one individual, this is another individual. Both are not same. So during the course of inheritance, I can pass A and A single dash only to the next generation. And this individual can pass only this to the next generation. But these genes A double dash is not present on my chromosome, thus it is not linked to my genes. Thus it cannot exhibit linkage. Because it is present on the same locus, okay, it cannot exhibit crossing over even. Next, the multiple alleles arise always by a mutation. The gene of the multiple allelic series from which another gene arises due to mutation is called as wild type, and the gene arising by mutation is called as mutant gene. Okay? They exhibit a gradation of dominant recessive relationship. This you have to remember. Multiple alleles exhibit a gradation of dominant recessive relationship where the wild type gene is dominant over all the other mutant genes. A single dash, double dash, triple dash, quadruple dash. That means in all, this is a series of 5 multiple alleles where A is dominant over all the other 4. Okay? All the other mutant genes, while a mutant gene will be a dominant gene to the gene which arises from it by mutation. And this is mutant, which is recessive to this one, but this is dominant to the one which arises from it. So thus A dash will be dominant to all these 3. A double dash is dominant to these 2. This one is dominant to this one, and this one is recessive to all the other 4. Okay? Next, when any two of the multiple alleles are crossed, the phenotype is of a mutant type and not the wild type in general, what they say. Further, F2 generations from such causes show typical monohybrid ratio for the concerned character. So because there is only one pair of genes involved in me, I can exhibit only the typical monohybrid cross ratio. Okay. There are different examples for multiple alleles. The well-known examples are wings of Drosophila, coat color in rabbit, and ABO blood group system in human beings. So examples for multiple alleles are wings of Drosophila, coat color in rabbit, and ABO blood group system in human beings. Okay. Now we are going to hello.
Sir, wings of Drosophila means what జనరేషన్ కి వెక్టర్ యొక్క షేప్ గానీ ఇంకేమైనా మారుతుందా సార్?
మారుతూ ఉంటుంది. మనం నార్మల్ వింగ్స్ అంటాం, వెస్టిజియల్ వింగ్స్ అంటాం, ఇలా చాలా రకాలు ఉన్నాయి వాటిలో. ఓకే. సో వింగ్స్లో వింగ్స్ షేప్ కానీ వింగ్స్ సైజ్ కానీ ఇలా మారుతూ ఉంటే వాటిలో డిఫరెంట్ వింగ్స్ వస్తూ ఉంటాయి. అలాగే rabbit skin is said to be having different colors. One is said to be, let us say, black, the other is said to be grey, and the other is said to be chinchilla, okay, and the other is said to be albino. So in all these cases there are different types of genes involved. We can call them as in this fashion. Okay. So there are different types of these. All these are responsible for only one character, that is coat color. And in one individual we can have only two genes. One is wild type, the other is said to be mutant. And likewise in human beings, ABO blood group system is also considered as example for multiple alleles. But whatever we have studied till now, only two rules apply. That is what that? It arose by mutation. Number two, they are more than two in number. But the gradation of dominant recessive relationship and other characteristics that we have studied do not apply for this. Okay. So let's see what actually the blood group, ABO blood group inheritance is. So it's an excellent example for multiple allele system. If blood from two persons is allowed to mix outside the body before the discovery of this one, sometimes it will mix well, and at other times there is a clumping of red blood cells. The reason for this was explained by Karl Landsteiner for the first time in 1900, who discovered, excuse me, hello, am I audible to everyone? Because somebody is calling me.
Yes, sir.
Okay. So the reason for this was explained by Karl Landsteiner in 1900. Karl Landsteiner discovered A, B, O, only three blood groups in 1900. In 1902, his students D. Castillo and Sterling discovered the AB blood group system. Thus we have four blood group systems. One is A, the other is B, third one O, and the fourth one AB. Coming to the discovery, how the ABO blood group system was discovered by Karl Landsteiner. Because he happens to be doctor cum scientist, what he observed is the ABO blood, he took blood samples from different people, separated the red cells from the colorless serum or plasma, and then mixed up them in various ways. He has taken the blood samples from the patients and separated the red cells and mixed them up in various ways. Mine with another way with the third person's with fourth person, and again the first person's blood with the fourth person and third person, and so on like that. He found that the red cells derived from one sample would mix smoothly with the serum of the same person. So the same blood that is taken from me is mixed with my blood it mixed smoothly. There is no breaking of the RBC, which we call it as clumping or agglutination. But when red cells of one person are mixed with the plasma of another person, sometimes the two would mix well. That means both are having the same blood group. At other times, there would be agglutination or breaking of RPC. That means they are not having the same blood group. This is what discovered by Karl Landsteiner by this experiment. On this basis of these reactions, Landsteiner and his students discovered four blood types in human beings: A, B, AB, and O. And coming to the discovery of antigens. Later on, Landsteiner found that human erythrocytes carry on their surface two distinct types of agents called as antigens. They are named as, because he do not know what actually it is. When we don't know whether it is a protein or a lipid or a carbohydrate or an enzyme, we just simply use the letters A, B, X, Y, Z like a mathematician. So he used the letters A and B for these two types, because during the combination or mixing of the bloods, he could observe only two different types of blood groups. So one blood group is said to be caused by one antigen, and this is given the name A, and the other is said to be called by him as B. And these A and B are agglutinating because they stimulate the production of specific antibodies. So thus, how you are going to say that there are four blood groups? Just simply have to say based on the presence or absence of A and B antigens. If I have A antigen, my blood group is said to be A blood group. I have B antigen, mine is B blood group. If I have both antigens, mine is AB. If I don't have any antigen, it is called as zero blood group. Zero blood group. So zero is spelled by Westerners as O. They spell zero as O, and hence this is called as O blood group. Okay. So what does O determine? The antigens are zero in this blood group. And where these antigens are present? Scientists say these antigens are present on the surface of RBC. So a person with A blood group will have only A antigen. Okay. And the person with B blood group will have on the surface of RBC only B antigen. And the person with AB blood group will have both antigens on the surface of RBC, and the person with O blood group will not have any antigen on the surface of RBC. That is what was discovered by these scientists. Okay. In addition to this, one significant feature of ABO blood group system is that we have natural antibodies. I am going to ask you in about 3 or 4 slides later, you have to answer me about this. Okay. So we have natural antibodies with respect to ABO blood group system. What do you mean by natural antibodies?
They are present within us without taking any medicines or injection.
Very good. So these are by birth. When we have antigens by birth, we call them as natural antibodies. So when let's say Samuel's blood group is A. So I am having A antigen. Whenever the antigen A is present, when good is present, there is always bad present. Okay. When antigen is present, against which there is an antibody is also present, and this is called as anti-A because this is against a antigen. This antibody is produced against, anti means against what? Against antigen A it is produced, hence it is called as anti-A antibody. So the same person with A antigen, if his blood also contains anti-A, what happens? Both react with each other, good and bad reacts with each other. What happens? One of them or both of them have to die. So the RBC is said to be broken down. So the person with A blood group should not contain A antigen. Likewise, there is a person with B blood group. So this person will be having antibody produced against B. If both are present in the same individual, he will die. Thus, one individual with A blood group will have anti-B, not anti-A in his blood. The other individual with B blood group will not have anti-B, rather he has anti-A in his blood. So where these are located? Let me say on RBC the antigens are present on its surface. Then what about the antibodies? They are said to be present in the plasma. They are said to be present in the plasma. When the plasma is collected and is allowed to clot, fibrinogen is removed and plasma minus fibrinogen is called as serum, and this serum contains all the antibodies present in this individual, and hence as this serum contains antibodies we call it as anti-serum. So we can call this one as anti-B serum, and this we can call it as anti-A serum. Okay, so what is the difference between plasma and serum? Plasma is all the fluid that is present in the blood vessel except the blood cells RBC, WBC and platelets. Then what is serum? Plasma, when it is allowed to clot, when we have an injury, some amount of blood comes out, and after some time, 3 to 5 minutes, it gets clot. After clotting, a yellow colored fluid comes out of the clot, and that yellow colored fluid is without fibrinogen, which takes part in blood clotting or blood coagulation. Thus, plasma minus fibrinogen is called as serum. Plasma is fluid, serum is also fluid. The only difference is it is without fibrinogen, and this serum contains all the antibodies present in the plasma. Hence, it is called as anti-serum. Thus, an individual, if it is said to be having A blood group, he will have A antigen and anti-B antibody. If it is B blood group, he will be having B antigen and anti-A antibody. If it is AB blood group, he will be having both antigens. If both antibodies are present, he will die. He will not have any antibody. O group individual is not having any antigens, but as we are saying, we have natural antibodies. Remember that. That means we are born with antibodies also. Anti-A and anti-B are both are said to be present. Okay. So thus, O group individual is born with anti-A and anti-B antibodies. So there occurs a question in your mind. So why A antigen? The A group individual has A antigen. Why not anti-A? So what actually happens is, in our blood there are certain genes. Okay, there are certain genes, and these genes are called as IR genes, immune responsive genes. IR genes are immune responsive genes. What happens is there are millions of antigens all and around us, in and around us, isn't it? We are continuously exposed to different types of bacteria, different types of viruses, fungi, and other pathogens, and we have to fight against them. If some bacterium enters in my body, what actually happens is that bacterium is having its specific proteins or carbohydrates or lipids, and some of that can act as an antigen because that is foreign to my body. My body cannot allow anything that is not mine. Okay, so if something happens to me and my cheek is said to be burnt, I cannot take my son's skin and just graft it on mine, because even though he is born to me, he is different totally from me. And my skin, my proteins, my carbohydrates, my lipids are my antigens, and we call them as self antigens. But when someone's antigen enter me, they are foreign antigens. The body can distinguish between self and foreign. How? When a foreign antigen enters, the immune responsive genes react in such a way that they produce antibodies against that antigen, and so that they are said to be dying. They are said to be clumping, and after that what happens? The antigen is said to be removed from the body. But I have self antigens. Where the antibodies are produced? The antibodies are produced from cells called as B lymphocytes. Okay, the B lymphocytes are in turn they form into plasma cells, and the plasma cells produce and secrete antibodies. So where the antibodies are produced? They are produced in the plasma cells. And after antibodies are produced, they react with the specific antigen, foreign antigen that entered by my body. And these antigens are broken down. They are destroyed by these antibodies. Let's say the same antigen, the same bacterium may infect me in future also. There is a thief entering in your house. Okay, what will you do? You fight against him. He comes with a knife. What will you do? You don't have knife. So what you have to do is you fight with him and you will die. So what actually the next time you will do? Will get a knife and be ready to fight with him. That means we have something in store to fight with the same antigen. Okay? Likewise, the B lymphocytes that which fought against these antigens remain as memory cells. They remain as memory cells. So whenever the same antigen again comes, it soon divides, produces plasma cells, and antibody production is said to be very fast. For the first time, to read the antigen and produce the antibodies, the immune responsive genes take some time. So the disease occurs in our body. That is what we call it as primary response, during which disease occurs, antibodies are produced and they are destroyed, and we are free of disease. So this is a natural phenomenon. We does not require any drugs or medicines for this. But at the same time, if the same antibody enters my body, what happens? There are already stored memory B lymphocytes, and these now recognize the antigen. That means it has already invaded my body prior, and these divide soon to form a multitude of plasma cells, and a number of antibodies are produced, and before the disease, the bacterium spreads in my body, all the bacteria are said to be destroyed, and this is called a secondary immune response, which is faster. That means we have B lymphocytes responsible for this production of antibodies. And what the scientists say is, for all of my antigens, my self antigen, I have antigens. That means antigens are nothing but proteins, carbohydrates, and lipids. So I have antigens in my body. They are self to me, and my antigens are foreign to you. Okay? And I cannot have B lymphocytes against my self antigens. What the scientists say is, the B lymphocytes responsible for the production of anti-A antibody because I have A blood group, I have, it is my self antigen, and this will be my self antibody. If I produce the self antibody, I will die. So my body recognizes that this anti A should not be produced, so that all the B lymphocytes which can produce anti A are said to be removed or destroyed during the embryonic development itself. Thus, I will not have any B lymphocyte that can produce anti-A antibody. But there are certain diseases, we call them as autoimmune disorders, where this system fails and our own antigens, self antigens, are recognized as foreign antigens and antibodies are produced against it, and we call them as autoimmune diseases. But so far, for A and B blood group system, there is no autoimmune disease. Thus, A individual will have only anti-B, which cannot react with this. B individual will have anti-A only, which cannot react with this one. So thus, we have natural antibodies produced by birth even. Why? We have two kinds of substances. One, which is said to be A antigen, that is for fighting with the other person. We have antibodies, that is to defend us with the other person. So antigens are said to be to fight with the other person or individual or bacterium, and antibodies are said to be to defend yourself. You cannot have the same type of antigen, same type of antibody in your blood. That is the reason why we have only A antigen with anti-B and B antigen with anti-A in our blood. Okay. Uh,
Then for AB, which type of antibodies are present, sir?
because I have AB antigens, both antigens, anti B lymphocytes for anti A, B lymphocytes for anti B are destroyed in the embryonic development itself, so that I will not have antibodies in my blood. So blood groups, A individual will have A antigen, anti B. B group individual will have B antigen, anti A, and AB individual have both antigens. Because antigens are present, I should not have antibodies, I will not have any antibody. And O group individual, because it is he is not having antigen. Natural antibodies are with respect to AB antigens are absent in AB blood group.
Then what type of antibodies are present within them?
All different kinds of antibodies with respect to the only the foreign antigens will be present, but not with respect to your self antigens. No one will have self antigens. No one will have antibodies for self antigens. So because AB are self antigens, his blood will not contain antibodies for anti-A and antibody. But your blood is exposed to dengue virus, you will have antibodies for dengue virus. If your blood is exposed to typhoid virus, typhoid bacterium, your blood will have antibodies for that. So thus, these antibodies are stored as memory B lymphocytes in your plasma. But anti-A and anti-B antibodies cannot be present, because A and B antigens are your self antigens, because your blood group is said to be AB blood group. Okay?
Okay, sir.
Okay. So you know all about the blood transfusion. There will be a donor, there will be a recessive. So let's see how a blood transfusion has to be done. Just in 1 minute, I will try to recollect. There is a person who is called as donor. There is a person called as recipient. So what you have to see in donor and recipient. If a person is with a blood group, okay, he can donate blood to A, B, AB or O. There are 4 different individuals in his near vicinity who are patients. So we have to see to which of these 4 persons he can donate. Can he donate to all or not? Can anyone tell me, during blood donation, how much blood you will give?
250 ml.
it is 250 ml only. In this 250 ml of blood, which one is more in number? Antigens or antibodies or both?
Antigens.
Why?
Because only antigens can define the blood group.
That means this blood of 250 ml did not contain antibodies. When I am donating blood, am I donating only antigens or also antibodies?
Both, sir.
Both, sir.
Both I am donating. So when I am giving my blood to some person, I am giving antigens present on the surface of RBC, but and also antibodies present in my plasma. But the difference is antigens where they are present on the surface of RBC. We know every 100 ml, 1 cubic millimeter of blood contains 5.5 million RBC. So that means here 5.5 plus 5.5 plus 2.25. That means nearly there are 14 million RBC. Let's say each RBC contains 10 antigens. That means 140 million antigens I donate. When I give blood, 140 approximately, I can donate antigens. That means a number of antigens are entering the other person's body. But antibodies are not that case. Antibodies are said to be very less in number because they are present in plasma. Plasma should contain RBC, plasma should contain WBC, plasma should contain platelets, serum albumin, serum globulins, other types of hormones, and glucose, fructose, galactose, all the digested food. So everything should be present in the plasma. So antibodies, if they are more in number, one of the other substance will have to decrease. So antibodies are very less in number. We call this as a titer value. Titer means the amount of RBC present in the plasma is its titer value. So the titer value of antibodies when you donate is said to be very less. So when you are donating, your blood contains both antigens and antibodies. Let us say I have donated my blood 250 ml. I have given 140 million 40 million and 140 million antigens to the other person, but I have given only 1000 antibodies to that person, maybe very less. So in that person, these 1000 antibodies, what these 1000 antibodies are? Anti-B antibodies. Here, this person I am donating, B blood group individual who has B antigen, some agglutination takes place only with respect to 1000 antibodies that are donated from my blood. Because only 1000 RBC are said to be affected, or 10 RBC or 15 RBC, 20 RBC, there is no much difference. So when you donate, you don't say anything about the antibodies. What you have to see in the donor is you have to see what kind of antigen is present. So in the donor, you have to see what kind of antigen is present. So this person is having A antigen. So A antigen is donated to all these 4 individuals. Now what happens? A antigen reacts only with anti-A, and we have to ensure that the other person is not having anti-A. So in that recipient, what we have to see, what kind of antibody is present in that individual. So this person, the first person is having anti-B, and I am donating A antigen. So A cannot react with anti-B, so I can donate blood to A blood group individual. The second person, B blood group individual, is having anti-A, and this person is having my A antigen, which can react with this one, so that agglutination take place and he will die. So for B blood group I cannot donate. And coming to the AB individual, he has no antibodies at all, so I can donate it. O group individual, he has 50% anti-A and 50% anti-B. That means 50% of the blood may get clumped with the antigens that I am donating. So I should not donate blood to this person. So thus, whenever you see a donor and a recipient, what you have to observe in donor, you have to observe what kind of antigen this person is having. Whenever you observe a recipient, you have to see what kind of antibodies are present in this. So this is what you have to observe. So during blood donation, donor, you have to see what kind of antigen, and recipient, you have to see what kind of antibody based on which you can transfuse the blood. Okay. And after this, before Bombay phenotype, let me explain you the second blood group. So there is another blood group system that is evolved, discovered by Landsteiner and Wiener. So Landsteiner, okay,
Excuse me, sir.
please.
So
So
then for
then
O
for O
blood
blood
group,
group,
no
no
antigens of
antigens of
A,
A,
no
no
antigens
antigens
of
of
B,
B,
no.
no.
So
So
can we
can we
give?
give?
You tell me. I'll draw the picture here. O group individual. There are four individuals: A, B, AB, and O. O group individual. Is he having any antigen?
No,
No,
sir.
sir.
No. So when no antigen is present, whether antibody is present or not is immaterial. So he can donate blood to all of them. Hence we call them as universal donor. Okay. Likewise, AB. So can AB donate blood to all of them? Because it has both antigens, he can never donate blood to anyone because he has antigen. So simple logic. What you have to see, whenever there is a question like this, you draw this one. You see what kind of antigen is present, what kind of antibody is present. Based on this, you can simply say whether it can donate it or not. Okay. Now, Landsteiner and Wiener were, please.
సార్
సార్
ఇప్పుడు
ఇప్పుడు
ఏబి
ఏబి
బ్లడ్
బ్లడ్
గ్రూప్
గ్రూప్
ఎవరైనా
ఎవరైనా
తీసుకోవచ్చు
తీసుకోవచ్చు
చేద్దాం
చేద్దాం
సార్
సార్.
మరి
మరి
ఇప్పుడు
ఇప్పుడు
ఏ
ఏ
బ్లడ్
బ్లడ్
గ్రూప్
గ్రూప్
వాళ్ళు బ్లడ్
బ్లడ్
ఇచ్చినప్పుడు
ఇచ్చినప్పుడు
ఏ
ఏ
బ్లడ్
బ్లడ్
గ్రూప్ లో
గ్రూప్
ఉండే
లో
బి
ఉండే బి
యాంటీజెన్స్
యాంటీజెన్స్
ఏబి
ఏబి
బ్లడ్
బ్లడ్
గ్రూప్ లో
గ్రూప్ లో
ఉండే
ఉండే
ఏ
యాంటీబాడీస్
యాంటీబాడీస్ ఏ
ఏబి బ్లడ్ గ్రూప్ లో యాంటీబాడీస్ ఉండవు కదా. ఏబి బ్లడ్ గ్రూప్ లో యాంటీబాడీస్ ఉండవు కదా.
నేను
నేను
అడిగే
అడిగే
డౌట్
డౌట్
ఏ
ఏ
బ్లడ్
బ్లడ్
గ్రూప్ లో
గ్రూప్ లో
ఉండే
ఉండే
యాంటీబాడీస్
యాంటీబాడీస్
ఏబి
ఏబి
బ్లడ్
బ్లడ్
గ్రూప్ లో
గ్రూప్ లో
ఉండే
ఉండే
యాంటీజెన్స్
యాంటీజెన్స్
తో
తో
పోట్లాడవా
పోట్లాడవా
సార్
సార్?
మరి అదే కదా నేను చెప్పాను. నువ్వు బ్లడ్ డొనేట్ చేసినప్పుడు 250 ml ఇస్తున్నావు. 250 ml ఇచ్చినప్పుడు ఎన్ని ఉంటాయి? వెరీ లెస్, థౌజండ్స్ ఓన్లీ ఉంటాయి. 10,000, 5,000, 1,000, ఈవెన్ 500. సో ఈ 500 నా బ్లడ్ నుంచి అవతలకి వెళ్తాయి, వెళ్ళి రియాక్ట్ అవుతాయి. కానీ ఎంత బ్లడ్ లాస్ అవుతుంది నీకు? ఆ 5,000 ఆర్బీసీ మాత్రం పోతాయి. నీకు ఎన్ని ఆర్బీసీ ఉన్నాయి? 5.5 మిలియన్ ఆర్బీసీ ఉన్నాయి. అందువలన ఈ యాంటీబాడీస్ అవతల నీ ఫస్ట్లో నీ క్లారిఫికేషన్ ఇచ్చేసాను నీకు. నాలోంచి యాంటీజెన్స్ వెళ్తాయి, నాలోంచి యాంటీబాడీస్ వెళ్తాయి. ఏది ఎక్కువ రియాక్ట్ అవుతుంది? ఏది ఎక్కువ నెంబర్లో ఉందో అది రియాక్ట్ అవుతుంది. ఏది ఎక్కువ నెంబర్లో ఉంది? యాంటీజెన్ ఎక్కువ నెంబర్లో ఉంది. యాంటీబాడీ ఉంది, అది కూడా రియాక్ట్ అవుతుంది. కానీ దానివల్ల డేంజర్ లేదు. రియాక్ట్ ఏదైతే ఎక్కువ అవుతుందో దాని వల్లనే డేంజర్ ఉంటుంది. కాబట్టి యాంటీజెన్స్ వల్లనే డేంజర్. యాంటీబాడీస్ వెళ్తే రియాక్ట్ అవుతాయి, కొంచెం క్లంపింగ్ జరుగుతుంది. ఆ క్లంపింగ్ జరిగినట్టుని మన మ్యాక్రోఫేజెస్, లింఫోసైట్స్ రిమూవ్ చేసేస్తాయి, స్కావెంజర్స్. కాబట్టి మన బ్లడ్ క్లియర్ అయిపోతుంది, కొంచెం కాబట్టి. కానీ మొత్తం బ్లడ్ వెసల్లో ఉన్న అన్ని బ్లడ్ సెల్స్ కూడా క్లాట్ అయిపోయాయి అనుకోండి, 5 మిలియన్ ఆర్బీసీ ఒకేసారి క్లాట్ అయిపోయాయి అనుకోండి, ఏమవుతుంది? బ్లడ్ లో క్లంపింగ్ వచ్చేస్తుంది. అది అలా క్లంపింగ్, ఆ క్లాట్స్ అలా క్యాపిలరీస్ లోకి వెళ్ళాయి అనుకోండి, క్యాపిలరీస్ బ్లాక్ అయిపోతాయి. అంతేకాక మనకు ఆర్బీసీ బ్రేక్ అయిపోతే హిమోగ్లోబిన్ బ్రేక్ అయిపోతుంది. హిమోగ్లోబిన్ ఉండదు, ట్రాన్స్పోర్టేషన్ ఆఫ్ ఆక్సిజన్ జరగదు, నీకు ఆక్సిజన్ ట్రాన్స్పోర్ట్ సమస్యలు వస్తాయి, చనిపోవడానికి అవకాశం ఉంది. కాబట్టి రెండు ఇస్తావు, యాంటీజెన్ ఇస్తావు, యాంటీబాడీస్ ఇస్తావు. ఇదేం చేస్తావు? మిలియన్స్ లో ఇస్తున్నావు. ఇదంతా చేస్తున్నావు, థౌజండ్స్ లో ఇస్తున్నావు. ఇది రియాక్ట్ అవుతుంది, ఇది రియాక్ట్ అవుతుంది. కానీ దీనివల్ల మోర్ డేంజర్, దీనివల్ల దెర్ ఇస్ నో డేంజర్. లెస్ డేంజర్ కూడా కదా, దెర్ ఇస్ నో డేంజర్. దే కెన్ బి రిమూవ్డ్ ఈజీలీ. ఓకే
ఓకే సార్.
ఓకే. సో మీరు బ్లడ్ టెస్ట్ చేస్తున్నారు కదా, బ్లడ్ టెస్ట్ చేశారా మీరు డిగ్రీలో? హ్యావ్ యూ డన్? So, so in blood test, what you do is you take 3 slides, okay? And my blood, one drop, one drop is added. And to this, I add anti-A. To this, I add anti-B. To this, I add anti-H, anti-RH or anti-D. And I observe whether clumping has taken place or not. So we have 3 bottles for anti-A, anti-B and anti-RH serum. Okay? So these are containing, the bottles are containing antibodies, and my blood is having antigens as well as antibodies, but here it is said to be antigens more in number. So these antibodies react with this one, clumping may take place and clumping may not take place based on the compatibility. Okay, now my doubt is how these many number of anti-A antibodies are collected by the scientists or doctors all over the world. How do you collect the anti-A, anti-B and anti-RH antibodies?
It is universally dispersed.
In order to perform the test, I need anti-A antibodies. Where from these anti-A antibodies are collected? From human beings only?
If one person have anti-A and one person have same person have antigen B, anti-B serum.
Okay.
So from that person will take anti-B serum.
Okay. What's your name?
Leela Kumar sir.
Leela Kumari, your blood group is B. Okay? I'm saying that your blood group is B. That means you have B antigen, you have anti-A antibody. So I am asking Leela Kumari, I want to perform a test. I need nearly 1 million antibodies. Can you please donate your blood for the collection of these antibodies?
No sir.
Yeah, why? Because you will die, isn't it? So we cannot collect antibodies from human beings. What we do is, the poor animals are chosen for this aspect. What are the animal models for experimentation? They are monkeys, they are rats, they are guinea pigs. All these mammals are used for what we call, used as animal models for experimentation. So what the scientists do is, they take my blood, B blood group, it is injected into the blood of a rat or monkey or guinea pig. Now what happens in the rat's blood? Can anybody tell me?
If we have same antigen, it will mix with it. If not, it will due to elimination and clumpings.
Rat is not having the blood groups that we have. Then what happens now? Rat is not having ABO blood group system. It is having some other type of blood group system. Then what happens in the rat? Did you understand my question?
Yes sir.
What happens in the rat? What happens when bacterium enters your body?
Rabbit immune system response stimulated దానికి antibodies production చేస్తున్నారు సార్ B antigen కి.
Very good. Whenever a bacterium enters your body produces antibody, isn't it? So likewise, for this rat or monkey or guinea pig, B antigen is a foreign antigen. It is not itself antigen. Whenever foreign antigen enters, what does it do? It produces antibodies. Antibodies against what? Antibodies against B. So this individual will produce anti-B antibodies. Now what I will do? I collect the blood, get it clot, and take out the serum, and the same serum is now mixed with the blood containing B antigen and see whether agglutination is taking place or not. If agglutination takes place, I say this blood is containing antibody B. If agglutination is not taking place, there is no use for collecting this serum and using it for the blood group identification test. So in this way, by using animal models, we collect different types of anti-sera. Is it clear?
Yes.
Okay. Now, Karl Landsteiner and Wiener, they are working on a monkey, scientific name of which is Macaca rhesus. So let's say what they have done, I haven't seen. This is just an illustration. It's an example, okay, for understanding. So they have taken the A blood group. Landsteiner's blood group is said to be A. So he has taken the A blood group, and this blood group is introduced into the macaca, and macaca will produce anti-A antibodies. Okay, it has to produce at any cost. And now this blood is collected and it is clot, and serum is collected, and serum, I am thinking that it is having anti-A. So in order to see whether it has anti-A or not, what I have to do? Yeah, I have to mix it with again the same A group blood. So both these were mixed and agglutination has taken place. Then you can say that anti-A antibodies are produced by macaca. But you cannot confirm it with one person. You have to take the blood of another individual. So I have taken the blood of Leela Kumari, who is also having A blood group. Now what happened? Agglutination has taken place. Very good, excellent. I have done a very good job. I have collected anti-A. But somebody asking, Nagendra came forward, sir, check with my blood also whether that anti-A antibody is present or not. So here we have taken Nagendra's blood and we have mixed with this anti-serum, and they found that no agglutination took place in that blood. That means with some persons agglutination for the A antigen is taking place, and in some other persons agglutination with the same antigen is not taking place. That means for these two persons we are saying we cannot see now by our own eyes, naked eyes, we cannot see whether the blood contains anti-A antibody or not. Just by clumping reaction only we can observe with the naked eye. So here clumping is taking place in these two individuals. Then we say that anti-A antibody is present. But the same anti-serum, when it is mixed with another person with the same antigen A, that is, there is no clumping. That means we say that there is no anti-A. Is it possible? No, because either anti-A should be present, anti-A should not be present. And with this experiment, Landsteiner and Wiener discovered that this antibody that is produced is not against A antigen at all. Because if it is produced against an A antigen, it should react with the blood of Nagendra also. But it did not react with that. So they thought that in addition to A and B antigens, our blood also contained the third antigen, that is Rh antigen. Okay? It was named after the scientific name, species name of rhesus monkey, and they called it as Rh antigen. So when this person is donating blood, this person is not just sending A antigen, he is also sending Rh antigen. and this individual reacted with the RH antigen more maybe, and it produced anti-RH antibodies, and this individual is having anti-RH. So Leela Kumari is not having RH blood group, that means there is no antigen here, so that it cannot react with it. If she has RH antigen, this anti-RH antibody reacts with RH antigen and agglutination takes place. So why in these two persons agglutination has taken place? Because they are having RH antigen and this is said to be anti-RH antibody reaction has taken place. Why not in Nagendra? Nagendra is not having any RH antigen at all. Hence, and there is no clumping reaction. So with this experiment, what the scientists found is, on the surface of RBC, in addition to A and B antigens, we also have another antigen called as RH antigen. So those individuals with RH antigen are all called as RH positive individuals, and those individuals where the RBC contains either A or B, both, and none of the RH antigen, they are called as RH negative antigens. So thus we have two types of blood groups. One is RH blood group system. Okay, so the blood group here is RH positive and RH negative. Then what about the antigens? Here RH positive and individual has RH antigen. Here RH antigen is absent. Now tell me the antibodies. What kind of antibody should be presented? RH positive and RH negative. The antibody is anti-RH. So which of these two individuals should contain anti-RH antibody?
Sir, RH positive or RH minus antibodies?
No, RH minus, and there is no RH minus antibody.
Sir,
This is
anti-A antibodies, sir.
Tali, please. I am not asking about anti-A antibody. Leave about them. I have A blood group. I have anti-B antibody. Now I am speaking about only RH antigen. For RH antigen, if I introduce it into any other's blood, anti-RH antibodies are produced, isn't it? So when RH antigen is present, if the same person contains anti-RH, agglutination takes place and he dies. That means the person with RH antigen should not contain anti-RH. So in these two blood groups, which one is having RH antigen? Positive or negative? RH positive. So the RH positive individual should contain anti-RH or not?
No.
So he cannot contain anti-RH. Anti-RH antibodies are absent. Then what about the RH negative individual?
Though it is not have any RH, so it's not mandatory for presence of anti-RH.
So he is not having any antigen, anti-RH can present, isn't it? But I have told you before, with respect to ABO blood group system, there are natural antibodies. What do you mean by natural antibodies?
By birth.
Those antibodies that are born by birth. And here, natural antibodies are absent with respect to RH blood group system. You note it down. That means RH positive anyway, he cannot contain antibody. RH negative, as antigen is absent, he can have anti-RH antibody, but even in this person antibodies are absent. So natural antibodies are absent in RH negative group individuals.
Natural antibodies are absent, sir.
Anti-RH are absent.
RH type of antibodies are absent.
RH type of anti-RH antibodies, which should actually, when we born, we should have the RH negative individual, as in the case of AB blood group individuals, As A individual is born with anti-B, Rh negative can be born with anti-Rh. There is O group individual. O group individual is born with anti-A and anti-B. Because he is not having any antigen, he is having natural antibodies. And here also there is no antigen in Rh like O group. Still too he is not having any anti-Rh. That means in baby or blood group system, natural antibodies are produced by birth, whereas here these antibodies are not produced by birth. And thus Rh positive will have only Rh antigen, no antibody. Rh negative will not have neither antigen nor antibody. Is it clear?
Yes, sir.
So based on this, there is a disease called as hemolytic disease of the newborn discovered. Okay, and this you already have studied it, and we are going to discuss about this, which is also called previously as erythroblastosis fetalis, the term of which is now discontinued, and we cannot call this as erythroblastosis fetalis no more. We have to call it as hemolytic disease of newborn, HD and V in short. And this is also called as RH incompatibility. RH incompatibility. So we are going to discuss about RH incompatibility, ABO incompatibility, Bombay phenotype, blood group inheritance, how it takes place, what are the different genes that are required, the chemistry of the genotype of ABO blood group inheritance, we are going to discuss in the evening class. Before that, I have one question for you. Because you have already studied erythroblastosis fetalis, let me please answer one question. In erythroblastosis fetalis, which baby is affected? First baby or second baby? Second baby is affected. Okay? Is there any chance for the first baby to get affected due to erythroblastosis fetalis?
No, sir.
You
I think
search.
immune system, yes, sir. Immune bodies are produced in time for
Antibodies
first
are
baby.
produced in first
Yes,
babies.
sir.
Yes, sir.
Antibodies are
Antibodies are
produced
produced
that
that
time.
time.
Is there any chance for the first baby to die? That's what my question is. Yes or no?
No, sir. No, sir.
No. Search Google and come up with an answer in the evening. If you don't say, I'll explain you. Okay? Thank
Okay,
you.
sir.
God bless you. Meet you in the evening.
Thank you, sir.
So keep seeing the WhatsApp group. I have classes till 9 o'clock today. If they are over by 8 o'clock, I'll take class by 8 or 7. So based on this, so keep seeing the WhatsApp group from 5 o'clock onwards. Okay? Thank you.
Okay.
Okay, sir.